Hi, I'm Dr. John Thompson. I'm president and founder of ExtraktLab. Today I'm going to be talking to you about a CO2 versus ethanol extraction facilities and the cost for each of those. We're going to do some comparisons, show you what's required and what's not required. It's going to be a good time. Let's get started. One thing to note when you are starting a ethanol or a CO2 extraction facility is the solvent that you choose will have a huge impact on the requirements for your production facility. So one thing to really think about when you are building your facility is the type of liquid extractant that you're going to have. Ethanol is considered a Class 1B liquid. Class 1B liquids are liquids that have flash points below 73 and boiling points 100 or above in Fahrenheit. Class 1B liquids include like ethyl alcohol, for example. It's really important you know the class of your liquid, can really understand what the requirements are for your facility that is coming out of that. There are many different engineering standards that you need to be aware of when you're talking about flammable liquids. NFPA 30 is a good one, and they have all the flammable liquids code. There's also 29 CFR 1910, which is the OSHA code. There's a whole bunch of other codes, engineering codes related to that, HVAC codes. The NFPA has a tremendous amount of resources for you on this. But the thing to really take home is ethanol is a Class 1B liquid. You also need to know how much of that liquid is going to be in your facility. One thing that's absolutely true is that ethanol extraction needs lots of ethanol. Typically, you're looking at about a gallon per pound of ethanol. So if you're going to do 2,000 pounds per day, you're looking at approximately 2,000 gallons of ethanol for a day's operation. Certainly, reuse operations or using falling film, for example, may be able to keep up with the ethanol extraction to reduce the amount of ethanol needed in a facility. Reduce and reuse operations or recycling operations need to comply with the FDA guidelines for solvent reuse. This includes specifications back to its original state, testing, and validation. I'm not going to talk about that here, but it's a part of the operating costs that you need to be thinking about when you anticipate reusing solvents. Let's just say that you need about 2,000 gallons in an operation. The maximum allowed ethanol per control area for an F2 occupancy is 240 gallons. You can have up to 3 control areas. That means that in your facility, you can only have 720 gallons. That really limits the amount of extraction that you're really able to do in an F2 facility. And most people who want to be able to have their facility scalable, they'll look at H2 or hazardous occupancy. So ethanol required definitely exceeds the F2 occupancy. Therefore, H234 occupancy can be required by your permitting body. There are major costs associated with those added occupancy. I'm not going to go through all the specific things, but let me give you some examples. You'll have to have fire alarms every 120 feet. You have to have certain fire-resistant walls. There are a whole list of things that are related to occupancy, H2 occupancy buildings. Here is the table that drives the requirements. This comes from the International Building Code, and the IBC code is kind of used and replicated in the Code of Fed Regulations in the NFPA. So they've all kind of gotten together and harmonized what they consider to be hazardous inside a facility and hazardous outside of a facility. In the case of the flammable liquid, in the green bar, you can see a 1B liquid or a 1A liquid, a flammable liquid. Group when maximum allowable quantity is exceeded requires H2 or H3. You can see that if you don't have sprinklered building, it's going to be like 30. If you do have a sprinklered building, 120. Actually, you can double that if it's a sprinklered building. So it's actually 60 and 240. So that's really where you get that. And this is for storage. And you can also have that for use in closed systems and then use in open systems. You can see the very limited amount in use in open systems. So if you add all that up, you're really talking about not a lot of ethanol in your facility, maybe two totes, and you're pretty much limited out and you have to have a different occupancy. This really is a cost schedule that you can find at many different places. You can go to any of the building inspection departments, for example, and find out the cost to build. Architects will also have this cost to build. This is a comparison between F occupancy and H occupancy comparison. These are average costs to build per square foot for different types of buildings. And the different types of buildings have to do with how the building is constructed, what the walls are, what the ceiling is it metal construction, is it cement construction, is it a wood construction, and then also is it sprinklered or not sprinklered. So that's what the different types of constructions are. And you can see that say you have a 5,000 square foot facility, you're going to build it up, F2 versus H2, you're talking about a radically different cost to build that building for an F2 versus an H occupancy. And that just has to do with all the requirements for an H occupancy. So the numbers are going to vary from region to region and from country to country for sure. Just make sure that you are aware of the occupancy requirements for your building if you're going to go with an ethanol extractor. So what is scalability and why does it matter? Scalability is the property of your plant or your property and your equipment that enables the business to start small and increase production as demand increases. If an ethanol processor starts off with, say, half a ton a day, for example, or 500 pounds per day in an F2 occupancy building and then decides it wants to grow and add more and more, very quickly it'll realize that it's running into the limits as to the amount of solvents it can have in the building. A lot of people just skirt the issue and they just run anyway. Well, they're going against the permitting issues, safety issues. If they get caught, obviously that's an issue, and insurance is also an issue. So CO2 has no such limitations. You can have an unlimited amount in your building. It's an inert gas. There are things you need to do just from an alarming standpoint and also venting standpoint. In the event of leak, or for example, your alarm would trigger a contact closure, which would give you a vent fan. The vent fan requirement is about 1 CFM per square foot. So that's typically if you have a room and where you have your CO2, basically you can vent it out. 2,000 square feet would be the size of like a bathroom fan. A lot of the bulk CO2 is usually stored outside, and I know that a lot of people do that also with the ethanol that they have. So there are requirements for outdoor storage and indoor storage and how much you have in your facilities. Even the vessels, however, if you have 1,000-liter vessel for your ethanol, you still have a significant amount of ethanol in your facility at all times. So that's something to be thinking about. Equipment can be scaled easily to 5 to 10 tons for CO2, no problem. That's what's great about CO2. It's definitely more scalable within the footprint of an F2 building.
Hey, thanks for watching. We have many resources available for you to get your hemp operation up and running. Calculators, advanced extraction guides, distillation guides, CBD Jam Sessions. We have just lots of content. Links to which are in the description below, as well as the cards up above. I'd like to hear from you. What was your favorite part of the video? If you would let me know in the comments below, I'd be really appreciative of it. Also, don't forget to subscribe to our channel for more content like this. This has been Dr. John with ExtraktLab. Thank you and have a great day.